So let's move on to the next question, guys. So in this question, we have to find the current I1. Now, if you look at this whole question, it can be redrawn in a different manner, right? So it can be redrawn like this. Just I'm redrawing it for the sake of simplicity, so that you guys can see a very important point that I'm going to tell you. So I'm just trying to show you that this node, for example, this is node A. So everywhere this is node A is itself. Okay, so A and A only. Okay, so no, this is not A. Sorry, this is not A. This will be B. Okay, so it's like this. So I'm just trying to show you that one more will be there. Okay, so if this is node, for example, C, so this is node C, and from C to A I have drawn this, C to A I have drawn this, C to A I have drawn this, and the B node will be this one. Okay, so from C to B it is 1 ohm, and from A to B it is 8-volt battery. So this is your A node at the bottom. Okay, this is your A node at the bottom, and then from B to A again it is 5 ohm resistance and 1 ampere current. Okay, so this is the whole scenario. Okay, so I'm just trying to show you that this node A is the outer node. Now generally we solve such questions using nodal analysis, right? So we have to find this current, we'll be looking at it, there's no issue in it. Okay, so generally we solve such questions using nodal analysis, and first of all in the nodal analysis we assume that this the node which has maximum number of branches connected to it has zero voltage or zero potential, or it is grounded. Okay, so voltage at node A is grounded, we are assuming that. Okay, so simply voltage at node B will be 8 volt because there is a 8-volt battery connected here. Now let us assume that voltage at node C is V suffix C. So KCL at node C. Okay, so the outgoing current will be VC divided by 1. Okay, so here also the current will be, and the current here will be VC divided by 1. The current here will be VC minus 8 divided by 1. Okay, and here also the current will be VC minus 8 divided by 1. So the outgoing current through now node C will be VC divided by 1 plus VC divided by 1, VC minus 8 divided by 1 plus VC minus 8 divided by 1 is equal to 0. Okay, because at this node, for example, this is also node C only, na? Because this whole is node C. So the outgoing current is VC divided by 1, VC minus 8 divided by 1, VC divided by 1, VC minus 8 divided by 1. So from here we can see that VC is equal to 4 volt. Okay, so this node is at 4 volt, right? Now Now you can easily solve the whole question. Let me take another color. So since here it is 4 volt, the current in this branch, that is from C to A, this branch. Okay. Now the current in this branch will be 4 ampere. Okay. The current in this branch will be incoming 4 amperes. Okay. Because here it is 8 volt battery na, and at this point it is 4 volt and this is grounded. So the voltage drop across this resistance will be plus at the bottom, minus at the top, that is 4 volt. This will be 4 amperes. And this is 8 volt, this is 4 volt. So current will flow from top to bottom, that is 4 amperes. Okay. 1 ampere is going in this direction. So KCL at node B, you can see that 4 ampere is going downwards and 1 ampere is going to the right. So incoming current will be 5 amperes. So 5 ampere is coming here. So KCL at node A, you can see that 4 ampere is coming from left, 1 ampere is going outside, 4 ampere is coming from the left, 5 ampere is going outside. So I is also an outgoing current. So KCL at node A, 4 ampere is the incoming current and outgoing current is 5 ampere plus I. So I is equal to minus 1 amperes. Right. So in this question, you just have to, so if you are looking at the method that I'm trying to tell you is try to solve such questions on the figure itself, because these questions will never be lengthy. They will be tricky questions. So for example, in this question, I have applied only 2 things. First of all, I have used the concept that the node which has maximum number of branches connected to it is assumed to be grounded. So node A has 0 potential according to my solution. Second point is node C voltage is to be calculated using nodal analysis that I have already done. Now after calculating the voltage of node C, you just have to apply the Ohm's law and the KCL equation. So by applying the Ohm's law, we can find that in this branch, the current is from bottom to top 4 ampere. In this branch, it is 4 ampere C to A, this direction. In this branch, B to C, current is flowing from top to bottom 4 amperes, and then KCL will help me to find out the value of the result. So I is equal to minus 1, right? So let's move on to next question, that is question number 13. So in this question, there is an infinite series of the resistances as we can see here. So first of all, I will just copy the question. Sorry. Okay. So we have to find the which of the following is true. Okay. So we have already done these kind of questions in class 12th itself, right? So we have to find RA. Now we can see that since RA is an infinite series, so if I break the series from here, then also the resultant will be RA itself. That is so what I'm trying to say is that if this is node A, this is B, this is C, and this is D. Since it's an infinite series of resistances, the equivalent between C and D is equal to the equivalent between A and B, because it's an infinite series. So this can be redrawn as I'll just write the statement. Since it is an infinite series, thus equivalent resistance between AB is equal to CD. Okay, so this can be redrawn as so CD. Now since the equivalent resistance between CD is RA itself, so I will draw RA. This is one, and again the equivalent from looking through AB terminal is RA. So from here I can say that RA is equal to 2 plus 1 parallel RA. That is 2 plus RA divided by RA plus 1 is equal to RA. Okay, so from here I can say that RA square plus RA is equal to 2RA plus 2 plus RA. So the equation that I will get is RA square minus 2RA minus 2 is equals to 0. So solving this equation I will get two results. Okay, and one will be positive, one will be negative, so I will take the positive result, that is under root 3 plus. Okay, just for sake of explanation I will write the solution for you. RA will have two solutions. So I can say that RA will have two solutions, that is minus B plus minus under root B square minus 4AC divided by 2A, right? So that is 2 plus minus B square is 4 minus 4AC is, so A is 1, C is minus 2, so it is plus 8 divided by 2, that is 2 plus minus under root 12 divided by 2, that is 2 plus minus 2 root 3 divided by 2, that is 1 plus minus root 3. So the, one solution is positive, one is negative, so I will take RA is equal to root 3 plus 1. Okay, this is how I get the solution. So now I have to find RB. So there is a difference in the figure of RA and RB. So if this is A and B terminal, okay, and this is C and D terminal, so since it's the infinite series resistance, I can say that the equivalent between C and D is equal to the resistance equivalent between A and B. Okay, so this figure can be redrawn as okay, so the equivalent between C and D is equal to the equivalent between A and B. So I can say that equivalent between A and B is RB, equivalent between C and D is again RB. So here RB is equal to 1 parallel 2 plus RB, that is 1 into 2 plus RB divided by RB plus 3. So this can be again seen as RB square plus 3RB is equal to 2 plus RB, that is RB square plus 2RB minus 2 is equal to 0. So after solving this we can say that RB is equal to minus B plus minus under root of B square minus 4AC divided by 2A, that is minus 2 plus minus under root B square, that is 4 that is 8 divided by 2, that is minus 2 plus minus under root 12 divided by 2, that is minus 1 plus minus under root 3. So we will take the positive part. So RB is equals to under root 3 minus 1, and RA was under root 3 plus 1. So easily we can say that this is not the answer, this is not the answer. RA is less than RB, this is also not the answer, so this will be the answer. Okay.